what I need you to do is draw your best circle. It should maybe take up like a third of your page because you're going to need to label it and do a bunch of stuff on there. So get me your best circle to represent a compass. And then that compass we will label with north, south, east, and west. What I'd like you to do is put them on the inside. So north, of course, is the top. Yeah. Oh yeah, whoops, B. And then we've got east, south, I'm going to work on the primary assumption that you know those compass headings. And then the compass is divided smaller than that, just like we take a degree and then we divide it into a minute. We take a minute, we divide it into a degree. The compass headings are divided also. And so that's divided into like northeast, southeast. So you've got northeast here, southeast, southwest, northwest. Furthermore, we divide that. All right, so let's focus on the north and the east section, and those are divided up a little bit further. And the first one is called north dot northeast. So it's like a combination of the two that it's between. A lot of times that dot isn't written there, it's just written NNE without the dot there, but it stands for north, northeast. And then the lower one, you always put the main compass heading first when you list it, the main compass heading being north, south, east, or west. So I put east first, and then northeast. So this is east, northeast. But it always is the like primary compass heading first. And so then when we go down below, those are further subdivided. And it would be east, southeast, and then south, southeast. So it's whatever major compass heading point it's closest to. And then you can go all the way around. That's closest to south and next to southwest. Closest to west, then southwest. And then finally west, northwest, and north, northwest. Okay, each of these headings on a compass, I'm going to circle the main ones. The main ones are worth 90 degrees. 0 is always at north. Okay, so that's what I'm going to put on the outside of my measure of my compass. So that would be where 0 degrees is. And then you count, so in a clockwise direction, so 90 degrees is east, 180 degrees is south, 270 is west. Okay, the last one should be 360, but by the time you get to 360, you're back to 0 again, so you start over. So really the last one would be like right here, it would be 359, that tiny little measurement. And then when you get to 360, you start over with 0 again. And so then you should be able to kind of figure out where the other values are. So since northeast is exactly in the middle, that's 45 degrees. And then you kind of work your way around in increments of 45. So 135, 225, 315. That's in increments of 45 degrees. And then if you go even smaller, what will those increments be? 22 and a half, yeah, 22 and a half. And so you should kind of be able to figure out, oh, well, that's 22.5. And so I should be able to figure out the next one being 67.5, etc. I'm not going to fill every single one of those little ones in, but you should have the idea of how much those are, and you should be able to figure those out. Okay, how is this connected to trig? Knowing how to read a compass bearing or a heading translates into creating a reference triangle. And so that's what we need to think about today, is how to create reference triangles for every compass heading. And so that is our goal, objective today. Okay, to know how to create a reference triangle out of a bearing. All right, the first thing you need to know about bearing is when you create these reference triangles, I'm going to practice with 4 of them with you. We're going to do 38. We are going to do 110. We're going to do 227. And we're going to do 301. Okay. Let me show you how to do one that's less than 90 degrees. All right, 38 degrees. So we know where 0 is, and we need to approximate 38. I'm not going to have you get a protractor out and figure it out perfectly, okay? But you know where 45 is halfway, so 38 should be, not quite halfway, maybe that much, 38 degrees. We connect our hypotenuse to the end of that mark. Then we create a reference triangle. And remember, a reference triangle always has to go down to the x-axis, like this. The 38 degrees is outside of the reference triangle. That yellow arch is not in the inside any part of the reference triangle. And so I need to figure out what is actually inside the reference triangle, because it's not 38 degrees. What would be inside the reference triangle is the rest of the 90 degrees that would be beyond 38, and so that would be 52. And so what actually goes inside the reference triangle is 52. The most common mistake when people create reference triangles is they just plop the 38 right in there. The 38 is actually outside, similar to a depression angle being outside. And so that would be a reference triangle created for 38 degrees. I'm going to use the same reference triangle right now, the same grid, and I'm going to do the 227 with you. All right, so let me show you how to do that one. All right, so 227, that starts at 0 also, but 227 is going to be in what quadrant? In quadrant 3. So you got to count by 90s. There's 90. There's 90 more. That's 180. How much more do I have to go yet? How many more exactly degrees do I need to go? I did 90, and I did another 90, and I'm doing the 227 one. I need to go 47 degrees more, and then stop. Label that 47 degrees. You want to keep track of how many beyond the quadrant that you did. You don't need to write 227 anywhere on your picture. You just need to keep track of how much past 180 that you were. And the hypotenuse is going to go to that mark. The reference triangle, again, connects to the x-axis. 47, just look at the yellow color, is not actually in the reference triangle. It's outside of the reference triangle. And so you got to do the work of figuring out how much is actually in the reference triangle. And that would be 43 degrees, because that's how much is left to get to the next, to finish that quadrant. Okay, all right, and so then I label it 43. Do you see how those numbers add up to 90 degrees? Like 38 and 52 add up to 90. 47 and 43 add up to 90. When you end up in a quadrant, the angles all have to add up to 90. Okay, I think I'm going to need to draw a fresh one for the other two that we haven't done yet. Just because it's going to get a little crowded. So I'm going to draw, if you've got space on yours, I suppose you could do it all in the same, but I'm going to draw it separately. All right, I want to do 110. Okay, when I draw 110, what quadrant will that end up in? Quadrant 10, 110 ends up in quadrant 4. All right, when I draw 110, I count by 90s. Okay, there's 90. And then a little bit more, and there's 20. Don't actually put the number 110 on your drawing. Only put the amount that was beyond the quadrant line. Okay. Then draw your reference triangle. I'm going to put my 20 out here. Okay, now I'm going to draw my reference triangle. Reference triangles go like this. Now in this case, the 20 is actually part of the reference triangle because the 20 is the yellow and the green like line up with each other. And so in the corner of the reference triangle, I also will put 20. Simply because in quadrant 4, the way a reference triangle is drawn is different than how it's drawn in 1 and 3. In 1 and 3, they've got to add up to 90. In 2 and 4, they're going to overlap with each other, so you count them as exactly the same. All right, and the last one is 301. I want to do 301 with you, and I'm going to do it on my same. Okay, 301. Okay, count by 90s. So 90, 180, 270, and then I got to get to 301. About there. The number 301 doesn't actually go on my drawing. What goes on my drawing is how much beyond the last quadrant I was. So if I did 90 and then 180 and 270, how much more did I go into that quadrant? 31, so it's 31 degrees. I draw my reference triangle there. And because I'm in quadrant 4, I use 31 degrees as my theta in my corner angle. So quadrants 2 and 4, when you draw the reference triangles, behave the same. Quadrants 1 and 3 behave differently. Okay, any questions on that so far? Okay, so now let's do some actual problems where we would use a compass heading. All right, so suppose you're flying a drone. Okay, there's all these rules with the FAA you have to have about how high you can fly it and what space you can fly it in, but suppose you're flying a drone and the heading that you have your drone is at 121 degrees. And you fly it for 15 minutes and you're flying it at 12 miles per hour. So I want you to draw a reference triangle. Draw and finish. All right. So now we're actually going to do a problem that has to do with the compass heading. So 121 degrees is going to put me into quadrant 4. So as I draw that, I don't actually use 120. Okay, keep that in mind. You don't actually use the bearing. You are going to use, okay, 90 and then a little bit more. How much more? 31 degrees. My reference triangle then would be created like that. And because I'm in that quadrant, then 31 is the value of the corner angle here. that's the drawing of the reference triangle. Now I want you to finish the reference triangle. Let me show you how to get the hypotenuse. The hypotenuse, when you have something that's moving, flying, is always the speed multiplied by the time. That tells you the length of the hypotenuse. So for this problem, the speed is 12 miles per hour. Now be careful about the units. The time is 15 minutes. Now I would not want you to do 15. That would be incorrect. Because 15 is minutes and the speed is measured in the unit of miles per hour. You can't mix your time units there. You've got to change one. So 15 would not be the right number to use. What is 15 in terms of a fraction of an hour? 1/4, right? We know 30 minutes is 1/2 of an hour, and so 15 is 1/4 of an hour. So that would be something you got to watch out for, are the units, and make sure that you are actually using not in minutes, but in hours. And so 12 times 1/4 is 3, so my hypotenuse is labeled 3. To finish the reference triangle, I need to label the sides. The sides of the triangle are labeled with the compass heading that they're pointed towards. So this one is pointed toward the east compass heading, so I label that east. The other side, the short side, is pointed straight south, and so I label that S. And now I want to find the east and the south sides of this reference triangle, and I just do some simple trig to figure that out. The east side is adjacent, which means I use cosine. So I do cosine of 31 degrees equals the adjacent east side over the hypotenuse of 3. And then we cross multiply. So east is equal to 3 cos 31. And then you type that into your calculator. The south side is opposite, so I use sine. So I'll have sine of 31 degrees. And that will equal south over 3, so we cross multiply. So south is 3 sine 31. And you'll use your calculator to finish that. So that's how you finish the reference triangle. You figure out the hypotenuse, and then you figure out the two sides based on their direction. Again, it's the direction that they're pointing in the quadrant that they're in. Okay, let's try another one. This time we're going to do a boat. Okay, so this time we have a boat going at a heading of 53 degrees on the compass for 2 hours. Hours is good. Minutes are bad, so hours are good. And it's going at a boat speed of 53 knots. Now that's because it's on the water. If it was on the land, we would say 53 miles per hour. Because it's on water, we say knots, which is the abbreviation for nautical miles per hour, and people just say knots instead of saying nautical miles per hour all the time. It's just because it's miles per hour on the water. Okay, it's not anything fancy. So you want to draw 53 degrees. Remember, 53 degrees is not actually part of your reference triangle. It never is. On a compass, the value you're given is never part of your reference triangle. It's how you figure it out. All right, so 53 degrees would be out about this far-ish. Okay, that's 53 degrees. However, the reference triangle does not actually have 53 in it. What does the reference triangle have? Not 53, but something else. 37, okay? We get 37 because they have to add up to 90. Now I want to find the hypotenuse. so I'm going to do the speed times the time. The speed is 53, and the time is 2. So the hypotenuse is 106. Then to finish and label this reference triangle, I look at the sides. So the bottom side is pointing east, and the vertical side is pointing north, and so I have an east and a north side to figure out. The north side is opposite, so I'll do sine of 37 equals north over 106 and cross multiply on that. The east side is adjacent, so I'll do cosine, and that will be east over 106. I'm not going to finish either of those. I know you know how to cross multiply and use your calculator to determine what those are. But you just got to get them labeled with the right direction. Okay, final one. Any questions on that? All right, you got one more. This is an airplane. All right, the plane is going off at a heading of 261 degrees. It's going at 425 miles per hour. And it's flown for 3.5 hours. Again, when the time is in hours, that's a good thing. So we want to create the drawing for that. 261 at 425 for 3.5 hours. All right, 261. Count by 90s. 90, 180, 261 gets me all the way close to 270, but not quite. So my reference triangle is very small. I did 90 and 90, and then I've got 81 degrees here. That's how much I had left. Okay, 90, 90, 81. If you want to keep track, this was 90, this was another 90, and then 81 is the total for 261. So how much is actually in the reference triangle? 9. Super small. What? Okay, so it's a really small reference triangle of only 9 degrees. The hypotenuse is going to be 425 as the speed times 3.5 hours. I forget what that is. I got 1,487. Can you check that? 425 times 3.5? Okay. So it's a really long hypotenuse. It's a very small triangle with a degree, but a very long hypotenuse. And so then the triangle has 2 legs. The triangle has a west leg, and it has a south leg, west and south, because of how the reference triangle is drawn. I don't really like how that turned out. And then you can just set up with your SOHCAHTOA trig for each one. We know the west is adjacent, so we'll do cosine of 9 degrees is the west side over 1487.5. And we know the south side is the opposite, so that would be sine of 9 degrees. That would be the south side over 1487.5. Okay, and then cross multiply and you got your answers.